All right, we are. Let us start central force motion. Central force motion or central force is given by F is equal to F of R into R cap. So it means if you consider a point like this, some other point is here, a force acting in between these 2 points along the line joining, it can be in inward direction or in the outward direction. Okay, so that kind of forces acting on a line or in a direction R, so there is only a radial direction. Okay, that kind of forces are called central forces. Okay, this we are going to in a very detail in this chapter. Okay, so Fr is f of r, the small f of r can be any function of r. For example, it can be r itself or 1 by r square. For example, in our Coulomb force, it is k into q1 q2 by r square. Gravitational force, spring force, planetary motion, these are all comes under these central force motions. So here r cap is a unit vector along the line of centers of the particles. Central force motion have different properties, such as its energy is constant of motion, angular momentum is a constant of motion, and the motion is confined, very importantly that the motion is confined to a plane. We will discuss in detail all these properties in a later class. Before that, let us consider an isolated system consisting of 2 mass points m1 and m2. Okay, so according to these coordinates, the position vector for m1 is r1 and that of m2 is r2. The relative distance between m1 and m2 is r. So r is the distance between m1 and m2 and it is towards m1. And r cap is this one. R cap is unit vector in the direction of r. Okay, so from this one we can have this r vector, this r is equal to r1 minus r2 by this triangle. Okay, or r2 plus r is equal to r1, from that r is equal to r1 minus r2, right? So this is r is equal to r1 minus r2. Now we want to know the equation of motion of the masses. For the first mass m1, the equation of motion is Newton's law, F is equal to ma. So this is m1 r1 double dot is equal to f of r cap, and m2 r2 double dot is equal to minus f of r cap. Why the minus? One, so minus means one is attractive, other is repulsive, something like that. So I am giving that f of r is less than 0, that means it is negative, it is an attractive force. If f of r is greater than 0, means it is positive, it is a repulsive force. Okay, so we want to solve these equation of motions. For that, in order to make the problem more simple, let us switch to a new way, that is, instead of using r1 and r2, we are using small r and capital R. Small r is r1 minus r2, and capital R that you have learned in last semester, r is the center of mass vector. This vector means a vector from origin of your coordinate to the center of mass point. Okay, center of mass of these 2 masses m1 and m2. So r is given by m1 r1 plus m2 r2 by m1 plus m2. Okay, and now suppose there is no other external forces. If there is no other external forces, r double dot is equal to 0. So there is no external forces, so f is 0, therefore r double dot is equal to 0. If you double integrate, you will get r. First integration you will get a r dot, second integration will give you r. So that will be r is equal to r0 plus vt. So what is r0 and v? R0 is some initial point of r. Okay, that depends on the way you select the coordinates, and v is the velocity. In order to understand that, let us assume the coordinate I choose is in this line with the center of mass as the origin. Okay, if center of mass as the origin, then r is 0. Okay, this is 0, and r0 is 0. And what about velocity? There is no velocity. Okay, is it clear? So that in way you can choose r0 and v according to your coordinate selection. Okay, let us understand a little more about this. So we want to calculate the r equations. Okay, we want to solve this equation. For that we follow this method. So our first equation is m1 r1 double dot is equal to fr r. I am going to multiply both sides with m2. Okay, that will give you m1 m2 r1 double dot is equal to m2 f of r, and to the second equation m2 r2 double dot equal to minus f of r cap is multiplied with the m1 on both sides will give you m1 m2 r2 double dot is equal to minus m1 f of r cap. Now I have subtract this from this one. Okay, so what I am getting is m1 m2 into r1 double dot minus r2 double dot is equal to m1 plus m2 into f of r cap. Okay, by subtracting, then I take this to the left side. So this will be m1 m2 by m1 plus m2 into r1 double dot minus r2 double dot is equal to f of r cap, and m1 m2 by m1 plus m2 is known as the reduced mass. Okay, it's known as the reduced mass, and r1 minus r2 is r, means r1 double dot minus r2 double dot is r double dot. Okay, therefore our equation become mu into r double dot is equal to f of r cap. Okay, so the problem is reduced to an equivalent one body problem. Now there is no two bodies. The two masses are replaced by its equivalent reduced mass mu. So this is a equation for a single body. Okay, so with this equation mu r double dot is equal to f of r cap, the two body problem reduced to an equivalent single body problem. So that this is this coordinate, this is your mu and r, and this is f of r cap. There is no two body problem. There is no two body problem. In that way, by the introduction of reduced mass, we are simply converted a two body problem to a one body problem. But remember, we are not able to generalize this, because if you have three bodies, you cannot find this method to solve. Okay, now let us understand a little more. So we have r is equal to r1 minus r2, and capital R is equal to m1 r1 plus m2 r2 by m1 plus m2. So I am going to replace r2 by r1 minus r. Okay, from this equation. Therefore r is equal to m1 r1 by m1 plus m2 plus m2 by m1 plus m2 into r2 is replaced by r1 minus r, and rearranging I will get these two are equal. So r1 minus this one. So from rearranging, what I am getting is r1 is equal to r plus m2 by m1 plus m2 into r. Similarly, if you replace r1 in the same manner, you will get r2 is equal to r minus m1 by m1 plus m2 into r cap. So vectorially it will be this one. See, r1 is r plus something, r1 is r plus something. So this is the direction. So this is the direction of m2 by m1 plus m2 r, this term. Similarly, r minus r2 is r minus, so this in this direction. So minus m1 plus m2 r is this one, these to this direction. Okay, what I am saying is these vector, okay, from center of mass to m2 and center of mass to m1, okay, is given by minus m1 by m1 plus m2 r and m2 by m1 plus into r. These are the position vector of m2 and m1 with respect to the center of mass. Okay, that's important. The position vector of m1 and m2 relative to the center of mass. Okay, so now we got understood the problem. But if you want to have a complete solution of this one, what we required is the exact form of f of r in mu r double dot is equal to f of r r cap. Okay, that we will do in a later time.